Hello, everybody, and welcome to our intro to machine learning tonight. Machine learning for cybersecurity, let me throw that in there, this evening here in the Pacific Coast. Dee Dee, the transcript, you should be on the bottom of your screen. You should be able to turn on the live transcript or CC, closed caption. It should be there. Let me share my screen so that we can get this up and going. Here we go. All right. Hello, everyone. Welcome to Intro to Machine Learning for Cybersecurity. We're hosted by Flatiron School and SecureSet Academy. We're glad you just decided to spend a part of your morning, afternoon, or evening with us, learning a little bit more about the in-demand field of cybersecurity. I am Tiffany Webb. I am the Director of Product Marketing and Events. I host events like this so that you guys can better understand how cybersecurity works, how it can protect you, or in this case, you'll learn about machine learning and how that works. I'll be the behind the scenes person tonight while you learn from our wonderful host, Asta, who is one of our cybersecurity instructors at Flatiron School and SecureSet. Before I hand it over to Asta, here's our agenda for the evening. We'll start out with an introduction of Flatiron School for our new friends in the audience, and we'll end with audience Q&A and next steps. Throughout the evening, throughout the event tonight, feel free to drop your questions in the Q&A box, and we'll get to as many as we can at the end of the programming. Asta will speak probably for the first 30 minutes, going over her lecture, and then we'll be happy to answer any questions you have on the specific topic or what it's like to study at Flatiron School. Which, speaking of, Flatiron School, was founded in 2012 in New York City. Flatiron is an award-winning boot camp that has helped thousands of graduates break into tech and land jobs they love. We believe that education is the best investment you can make in your future, and we're committed to helping you learn the skills you need to change yours for the better. Hence our mission statement shown here to enable the pursuit of a better life through education. We currently offer career-changing courses in software engineering, data science, cybersecurity, and product design with flexible pacing options to fit your life or lifestyle. We have campuses across the country in these cities, in Austin, Chicago, Denver, Houston, New York, San Fran, Seattle, and DC. Our sister school, SecureSet Academy, also operates in Denver and Colorado Springs. Our true differentiator is our proven job search framework, which has helped thousands of our grads break into the tech industry and land jobs at places like this. Spotify, Etsy, Google, Porch, Infosys, and so many more that are not mentioned here. These are just the big names for you. The best boot camps get graduates jobs and, are happy to prove it. So our 2020 jobs report is third-party verified and available on our website in full, but here's a peek. In 2020, 86% of our campus and online students were placed. That doesn't mean that the other 14% did not fill in the gap over time. It's just in this time frame. And the average US starting salary was about just under $75,000. So yeah, we're doing good things and making sure that people get jobs in places they love and make good money while doing it. I'm going to stop share right now and pass the proverbial mic over to Asta, who will be our fearless instructor this evening or morning, wherever you are. And Asta, would you like to introduce yourself and share your screen?
Thank you, Tiffany. Hello, everyone. So we are going to just start soon. And as Tiffany mentioned, I'm one of the cybersecurity instructors here in Flatiron School, and a little bit more details about me I will be sharing once I start with the presentation. The first 30 to 35 minutes I'll be taking for the presentation, and after that I may take any Q&As that you may have. I can see there are a few questions in the Q&A, but I think once we go through the session, maybe your answers, maybe your questions can be answered automatically via the session. And if you continue to have that question, we'll be definitely taking them. So let's get started. I'm going to share my screen now. So can you see my screen?
Yes, I can. You're good to go.
Okay. So we are here to today learn about how we can integrate machine learning in cybersecurity operations. So the major of our talk is going to be a little bit about machine learning, what it is, and how we can integrate it with cybersecurity. So before we start, a little bit information about myself. As already shared, I'm one of the cybersecurity instructors here in Flatiron School. Along with that, I'm running two of the initiatives. One is Lean in Breaking Barrier Circle, which is for women in cybersecurity. And I'm also running a YouTube channel, which is known as Cyber Preserve, where we share cybersecurity related talks, sessions, and interviews. Along with that, I work with OWASP. So I'm one of the committee members for OWASP Women in AppSec. The agenda for today's talk is like, it will go like this. We'll first start with intro to cybersecurity, basically just a basic understanding of what cybersecurity is. And then we are going to proceed towards the challenges. And basically the challenges will come from, as we talk about big data, then challenges. Then I'm going to proceed towards machine learning. So the major chunk of the lecture would be about introduction to machine learning, what it is. And the second leg of the lecture or the session would be about how we can apply machine learning in cybersecurity operations. So what are the ways, what are the types, and what are the gaps, what are the conclusions, and what can be the future steps? So of course, as we talk about new topics, always when we talk about new integrations, there are always positives and there are always negatives. So we are also going to cater the same. We are also going to cater what are the benefits, and we are also going to cater the gaps that we need to fulfill in the next upcoming years. So first of all, what is cybersecurity? In the simplest of terms, cybersecurity is the area where we are trying to understand cyber attacks, and we try to build defensive measures in the form of processes, technology, and control in order to prevent them or handle them better. Cybersecurity works on three major pillars, which is confidentiality, integrity, and availability. Both of these, like all these three terms, what they actually mean is confidentiality means any information that is shared between certain set of audience should be secured and accessible to them only. Integrity means any information which is there on a communication channel or it is stored anywhere. It should not be modified by anyone in an illegal manner. So it's basically like preventing tampering of information. Availability means, let's say, one of the simplest example of availability is, let's say you are accessing Facebook. Everybody can access Facebook or google.com. So if any day you're not able to access them, it means your availability has gone. So availability ensures that whatever information you should have access to, you should be able to access it. And cybersecurity ensures these three pillars while we implement any of the technology, processes, and controls. Now, as I said, we are going to transition towards the usage of machine learning in cybersecurity operations. And in order to identify like why do we need machine learning in cybersecurity operations, we first need to learn the background of it. So the background starts with something known as big data. Now, what does big data means? Big data is nothing but the huge amount of data that has been generated over the years as we have grown using internet. So the amount of data that has been generated via applications, various devices that you use nowadays, like televisions, refrigerator, every device is capable of generating data nowadays. Everybody is using internet, from kids to youngsters to older people. We are so much used to internet now. So what it has led to something known as big data. Now, big data is something which has greater variety because all the type of data is being generated, like Twitter tweets, Facebook statuses, your LinkedIn posts, and various other applications where you post your reviews and whatnot. So the data's variety has increased considerably. Its volume has increased considerably. Now, what has it led to is larger amount of data being generated in a second. So more than petabytes or even more than petabytes of data is being generated in 1 second. How to handle this outburst of data? And this outburst of data is depending on 5 V's. What are these 5 Bs? The 5 Bs are basically velocity. As I said, the velocity has increased, the variety of data has increased, the volume has increased, veracity. Veracity is how much you can trust the data which is being generated on internet. There's so much data, Quora, like we post so much of our opinions on Twitter. So what's the truthfulness of the data? What's the value of data that we are trying to process? And along with that, the data which is being generated on internet can be in a structured form. Structured means easily readable. Once you extract that data from the back end, it's easily readable or not. What's the structure of the data? Is it structured, unstructured, semi-structured? Like your email. Your email is a semi-structured kind of a data. How? Because when you send an email, the body can be anything. You can put anything in the body of the email, but the subject part, to, send, CC, BCC, this is the structured part of your email. So big data consists of different types: structured, unstructured, semi-structured. But the velocity, the variety, the volume, the veracity, and the value is too much that we are depending on right now. Now, not just organizations or not just us, we are dealing with so much data. Cybersecurity is also dealing with so much data. Every now and then you see news, like you are watching news, you're reading news, so many articles like this attack happened, that attack happened. The attacks and their numbers have increased exponentially. Every now and then ransomware or zero-day kind of attacks have increased so much in number. And to be honest, we have some numbers right now in the slides, if you can see. So what has happened is, first of all, as I said, the number of attacks have increased due to the digitization, Internet of Things. Second, I have a number to show. So the number is about malware executables known to security community. So in 2010, there were like less than 50 million malware executable known. In 2012, they were around 100 million. And by 2019, they actually increased more than 936 million. That's the number which has increased. Now, along with that, in this year, so there has been a cybersecurity skill gap, which is ongoing. And Frost and Sullivan, they are one of the market research companies. What they have predicted is that this skill gap between the number of people who are hired and the unfilled jobs or positions will reach 1.8 million by 2022. So we have limited workforce, we have larger amount of data to handle, and most of the time, if we are relying on traditional approaches of security, let's say we are using intrusion detection system, antiviruses, then we are using tools like security information and event management, which we call as SIM. We are using variety of tools like firewalls. But the problem is, through these tools, we are responding. But now the attacks and the nature of the attacks have evolved. They have become more advanced and sophisticated. Now, how to deal with this ongoing challenge between the larger amount of information and limited workforce? And one of the ways to be proactive, basically, you are always aware of what's happening, how to predict attack before they can happen, or if the attacks are taking place, how to handle them better. So one of the implementations which can help cybersecurity operations is your machine learning. Now, many people think, and there is a myth as well, that in future machine learning or artificial intelligence, they are going to replace human, they are going to take away human jobs. That's not true. The reality is, when a particular analyst, engineer who is working every day, if they are spending more time in routine and redundant tasks, how they are going to focus more on advanced attacks. So the whole point of bringing machine learning is to focus on tasks which can be done by algorithms or automation, and rest of the more valuable tasks can be focused by humans. Now, as we say that, let's learn few terminologies about machine learning. So the very first one is artificial intelligence. So artificial intelligence is the broader area where we think, like where we bring the idea of getting machines who can exactly mimic like human, like robots. Machine learning is a subset of artificial intelligence where we are using different kinds of approaches in our algorithms, machine learning algorithms. And like The two of the ways are supervised and unsupervised learning. And inside machine learning comes deep learning, which is most widely used in our cyber operations. Now, deep learning, now they are each part of each area. So the biggest circle or the biggest area is artificial intelligence. Under that, we have machine learning, and under that, we have the implementation of deep learning. Now, what we are going to do is in the next upcoming slides, we are going to learn more about what are the types of machine learnings, like algorithms, supervised and unsupervised, certain example of different models which are applicable to each one of them with certain real-time examples. And then we are going to focus towards, like, now we have understood a bit of machine learning. Now how we can apply it in cyber operations, like what outputs it's going to bring it for us. So the very first type is supervised. So in supervised machine learning, what's happening is, let's compare this machine learning thing with our human brain. What happens is, whenever you learn something new, anything which you learn something new, you first try to absorb that information. If you don't know, you take more input from your outside environment to learn it. And next time when you encounter similar situation, now you are able to understand that particular topic or area better. So let's say when you are a child, you learn for the very first time how to speak words. So for the very first time when you are speaking, you just understand the essence of it. And when you continue to know, then you are in a position to remember things. And that's what supervised machine learning does. In supervised machine learning, we first train learning like we train our brain. So we train our machine with some data. Once the machine learns that data, then it tries to predict and basically, let's say, classify results for us. So two things are there. One is prediction, is to predict some result. One thing is to classify, basically categorize data into several classes. That's a supervised learning. Second one is unsupervised learning. It's a bit different, but very interesting. In supervised learning, what we do is we provide data to the machine learning model. It learns on its own and it predicts on its own. That's the beauty of unsupervised learning, that you provided data, you directly provided data. It tries to predict result for you using that data without training. Now, some of the most famous usages of supervised machine learning algorithms are logical regression. Regression is more associated with the term prediction. Then we have decision tree, XGBoost. These three are there are more supervised machine learning algorithms as well, but these three are majorly used in our cybersecurity operations. I was talking about a term in machine learning, specifically supervised machine learning, known as classification, or basically categorization. Now, you have a diagram on your right hand side where you can see that we have a training model and there is a prediction model. Look at the training part. In training part, you provide an input, and along with an input, you are providing a label. Label is basically the category, like is it class A, is it class B? So for example, if there are 5 sentences in the input, so those 5 sentences, and in those 5 sentences, how many sentences are positive, how many sentences are negative? That's their labeling, positive and negative. First, you train machine. You provide this training data to the machine. Machine learns it. Once machine learns it, then you provide any test data. Test data means now you provide any random sentence to it, and then the machine will predict for you, basically classify in this area for you, whether it's positive or negative. The next type of machine learning is unsupervised machine learning. So as I was saying, in unsupervised, we do not provide the training data. Like in previous, I shared here the training data. Here, we do not provide the training data. It learns on its own. Now, two of the major implementation of unsupervised learning is clustering. Under clustering, we have an algorithm known as k-means clustering. It's the very famous one. Now, what's happening in clustering is, if you look at this diagram, we are basically putting data in some clusters or groups. So basically, let's say there are 6 people, 2 say yes and 2 say no, and they are being categorized. So they become part of 2 groups. So cluster means like data belonging to similar groups, they got in the form of clusters, like this diagram shows. Now, a real-time example of cluster from cybersecurity is like if someone is trying to breach your network, let's say someone is trying to brute force your system. So they will try multiple times username and password and they'll fail multiple times. The multiple times they fail, that failure, the number of failure attempts, that becomes a cluster. So that's one of the real-time examples. Now, how in real life, like if you want to visualize how clustering look like, this is an example for you. If we have a sample, you can see there are different 3 colors of potatoes which are present here, and how you can, like basically you have a sample and how then they are resulted into a cluster where similar groups, they are present together. So now we have 3 clusters in the final output. The next one is the most interesting one, which is deep learning. Now, deep learning is an actively researched area till now. Deep learning is based on unsupervised machine learning. Now, what happened in case of deep learning is, if you can look at the diagram, it has 3 layers on how it works. One is the input layer, the input data. Then after the input layer, there is a hidden layer which processes result, and then you have a final output. This unsupervised machine learning, basically the deep learning, is somehow based on our biological brain neuron network. So in our brain, we have multiple neurons, and how our brain learns basically is when there is an input that goes in our brain, it goes to one neuron shares that information with another neuron in our brain, and this goes with the help of a chemical reaction. Then information passes from one neuron to another neuron, and when this information is passing, it's processing, which is the hidden layer, which I showed in the previous diagram. Here, the hidden layer. So what happens is when information passes and our neurons, they learn, they try to absorb. This is the similar structure we are applying in real time in artificial neural network, which is used in deep learning. Deep learning is very much used to predict, like if you want to utilize deep learning in your cybersecurity operations, one of the major areas would be malware classification, where we have to like, let's say you want to predict certain malwares or unknown threats. So unsupervised learning is best used when you don't know what it is and you want to predict it. Like you don't know that if certain data will come, how our machine is going to respond. So basically, if there is a training data in case of supervised learning, where where things are known, you train and they predict. This is more about like unpredictable things, new kind of attacks, new kind of malwares. So it's mostly apply in those category of advanced threats prediction. Another important aspect of machine learning is Python. Python, for some of you, if you don't know, it's a high-level programming language. It works with the help of indentation. And it's widely used in, of course, machine learning, data visualization, web development, automation. Anytime you want to automate a manual task, Python scripts widely used. I have shared one real-time example of data visualization via Python. So on the right-hand side is a small code which is using Python library pylab, matplotlib, and pandas. So pandas are mostly used for creating visualization from any data that you have. So in this code on the right-hand side, we have taken an input, a CSV file. We have taken a CSV file and using pandas, we have created a bar chart of that visualization. So basically, this visualization shows different, like Chennai is one of the countries in India. So it shows different Chennai areas, and along with the areas, it shows different tweets. So these are some Twitter tweets happening across different areas. So how many tweets and from different areas, traffic tweets. So this is how you can create visualization. As I said, Python is widely used for machine learning as well. So along with pandas, we have other libraries like NumPy. We have sklearn, widely used for machine learning, from regression to your k-means clustering. sklearn is there. pfile, Ngrams, and the last two are mostly for analyzing data. So once you have processed information, how to further analyze data, natural language processing, etc., can be done via the last two ones. Now, application of machine learning in cybersecurity. Like two examples I have given you while I was explaining clustering and deep learning. But in general, our major need is to like how to recognize unknown threats, classify certain patterns of attack, how we can use machine learning in, let's say, application security, risk assessment, or risk identification. So the major goal, the bottom line is we are looking for detection, like how machine learning can help us in better detecting advanced level threats, how it can help us in prediction, classification, and basically optimizing our like daily operations, how we can optimize, how we can achieve improvement, better optimization, or basically the term is how we can operationalize our security operations better with machine learning. Now, let's discuss some of the attack scenarios. Attack scenarios, like what can be the possible situation where you can think like, oh, there might be an attack. Like if, let's say, let's pick up the first example. So let's say it says for every file sent through the network, does it contain malware? So it's like every file which is being sent from your network or your network is receiving, does it contain any malware? For every login attempt that someone is doing on your network, has someone's password compromised? For every email received, how to detect or predict that it's a phishing email? For every request that reaches your server, how to identify it's a denial of service attack or not? So we are always on the verge of attack now. It's like everything is linked with it. Every action we try to think of, oh, is this attack or is that attack? How to keep on predicting these things better? So these are some of the attack scenarios. Now, what we are going to do in the next slide is we are going to more talk about machine learning and malware datasets. That's the next topic that we're going to cover. So one of the applications that we are going to discuss is how we can utilize machine learning in malware analysis. So what's happening is machine learning is started to be known for its three areas. First is fuzzy matching. Fuzzy matching means clustering, how we talked about unsupervised learning and cluster, how it can help us in grouping things together. Then the second one is automatic selection. Automatic selection is more based on, again, unsupervised learning. How? In unsupervised learning, when you don't have any training data, your machine is learning on its own. So basically, when it is processing any input, it automatically adjusts the weight of every input. So every input that you are providing to your algorithm, like basically to your model, for every input, it will extract some unique information from that input. So for example, very simple example is, let's say there is a sentence which says, I'm very happy today. This sentence has word happy. This word happy becomes a feature for your model. Through this word happy, your model will predict that it's a positive sentence. Same goes with any other prediction or input. Your model will try to identify feature. So the second thing is automatic selection of features. Third is adaptive response. Adaptive response is how your machine learning adapt to changing inputs. Let's say in cyber world, there are so many attacks which are evolving. So how your machine learning algorithm should adapt to changing nature of cybersecurity attacks, how it continues to learn on its own in order to predict attacks accurately in future. That's the three major important things we require when we are utilizing machine learning for cybersecurity operations. Now, how to find data sets? Because every time you are going to utilize a machine learning algorithm, it is somehow going to be related to data sets. Now, in case of malware, here's a picture which you are seeing on the slide. This picture shows a couple of data sets that can be used for malware analysis. So the very first one is malware traffic analysis.net. It has close to like 600 samples or more. Second one is Kaggle. So some of you, if you do not know Kaggle is a data science competition website where data sets are present. Companies like Microsoft and others, they put up data science competition, they pay the winners, and you can also create models on this web-based service, which is Kaggle. Kaggle also has malware model, like they have also samples. Then we have VX7, Virus Share, Virus Total. All three are related with providing information about viruses and other types of malwares. Virus Total is a website which can help you identify any kind of malware in your file or a hash. So all four of them or five of them, they have certain kind of samples, and these samples is something that it's the knowledge. Okay, so one thing that you need to understand is these data sets that I'm referring to, they are going to provide knowledge to your machine learning model. And once your model has the knowledge, then it will be able to classify or predict. Now, coming to the problems and gaps that we need to take care. So one of the problems is when we are providing some input data. So when the input data is provided to the model, there is a very good chance that if your model is inaccurate, it can have either too much of information of one type or too much of information of other type. That becomes minority or majority class. Then bias. Bias means, let's say we want to predict a type of malware, but most of your data set has information which is biased towards one category of malware. So if it's biased, again, it will provide inaccurate result. Label inaccuracy. Label inaccuracy is related to, let's say you're using supervised machine learning where you are providing labeled inputs, label training data. If that is set inaccurately, then machine will run inaccurately. Missing data. If you miss to provide any information to your model, maybe it will not learn, maybe it will not absorb, maybe it will predict results, but not so accurately. So these are some of the real-time challenges. I'm not saying these are theoretical challenges, they are real-time challenges. Anytime, any company which is working with data, and if biasness is there, if label inaccuracy there is, if missing data is there, the overall results of your model are always going to be inaccurate, and that is further going to affect whatever decisions you are taking further. So we really have to take care of this unbalanced data part all the time. And all organizations, from big tech to medium size to small organizations, they are always taking care of it. Now, let's learn about some of the ground truths. So some of the data problems we discussed. Now we have to talk about what are the ground truths around machine learning. So one of the ground truths is, like, I showed you a malware data set, but was it a standard data set? Like, is it like if you want to collect data about malware, you will collect only from those sites? No, maybe from more. So the problem is we don't have real standards for data sets yet. Like if we want to collect data for so-and-so type of threat, then which is the data set which can provide us the best set of information? How can we be sure about that? Second thing, deep learning or unsupervised learning, basically. These types of models, they are slow to learn because first of all, they're unsupervised. We do not provide them direct label training. They learn on their own. When they learn on their own, they take time. They are slow to predict. Supervised learning models, on the other hand, they require retraining again and again because they are dependent on your training models. If you see inaccuracy, false positives, false negatives, they're going to be there. But how do you actually overcome your false positive and false negative in both the scenarios? Sometimes it's retraining your data, or you have to improve. If you want to, you have to improve the performance of your existing algorithm, and you mostly do this by retraining your data and providing better data to your model. So the conclusion is, adapting to evolving nature of cyber threat landscape, it needs, this is the key. We have to be, the machine learning algorithms, they have to be more adaptive. The data has to be more standardized. And if this is there, then further our accuracy is going to increase and our false positives and false negatives are going to decrease. Now, recently there was a research which was going on cybersecurity data science. It was based on cybersecurity data science. That's the term, CDC. So based on that research, they suggested a final, basically a final structure of how our cybersecurity services along with data science might look like. So starting from bottom, it first starts with the cybersecurity infrastructure, like basically the normal architecture we have. Then it goes to, we are collecting data from multiple sources. While the data is collected, then we normalize the data. Basically, we look at if the data is structured, unstructured, semi-structured. So how to cater that data. Maybe you are using NoSQL databases for that. Then you are utilizing models, machine learning based models for classifications and predictions. And finally, whatever results these models are providing, using these results, you are either improving more or you're using them in your decision making. So of course, you are updating your existing security model, you are using the results in decision making, and you are improving your existing security operations. And this is it from my side. Thank you for joining me today. And here are some of the references for from the presentation. Over to you, Tiffany.
Awesome. Thank you so much, Asta. We have some questions in the chat, so I will get right to it. The rate, so this was before the presentation, but AR was wondering about the rate of false positives and rate of false negatives resulting from machine learning.
So the false positives and false negatives both are always there. As I said in the last part of the lecture, either you retrain your machine learning, like basically your models, because if there is inaccuracy, that is directly going to impact false positives and false negatives. So you have to retrain your models, and most of the big organizations, they have to do it. They have to retrain. They often require, let's say, if in general they require retraining, let's say in 3 years, they might require retraining in 1 year if there are more false positives.
Sorry, I was muted. Is it often advised in cybersecurity not to build your own security tools? What is the advantage of using machine learning to build tools that may or may not have gone through the same level of QA that a vendor product can provide?
So I'm going to read the question. So it's often advised in cybersecurity not to build your own security tools. Your organization, like many organizations, they have some tools which they have already, like they are private to the organization. They are using it for their own operations. So I don't think so. You're not advised, but definitely when you're utilizing any security tool, the testing is always done. The results are always seen, how accurate it is. Now, in case of machine learning, you're saying what's the advantage of using machine learning to build tools that may or may not have gone through the same level of Q&A. So build, like using machine learning to build tools that may or may not have gone through the same. So I'm not sure what kind of, are you talking about the security?
I think what this person is asking, like if you had a vendor provide tools for you, then it goes through like a Q&A process, right? So is there an advantage to using your own tools to build something, even though it doesn't go through that same level of testing?
It is. So the thing is, like, let's say you are starting to use machine learning. So when you're new, it's often you're using vendor provided products only because you're learning. You are going to hire people, the people are going to work. Once your team becomes more expert, and once they are more into, like, basically these kinds of area would be like, they would more go into the form where I would say there would be data science researchers, cybersecurity researchers. So it's a joint effort. Once you have more expert, your organization has grown to that level in that area, then you can start to use your own products. So this is like a capability maturity model kind of a thing.
Got it. In the chat, Chuck asked, could you recommend any open source machine learning solutions, i.e. GitHub, for analyzing PCAP files and developing machine learning models for supervised learning?
Where is this question?
It's in the chat, not in the Q&A.
Oh.
I'm trying to give a little love to both. Yeah.
I'm just looking. I don't see it in the chat.
So came at 5:43. Oh no, 8:43 your time.
8:43. Okay, could you recommend any open source machine learning solution like GitHub for analyzing PCAP files? Yes. So there are a couple of them on GitHubs, which are either using deep learning or they are using k-means clustering and logical regression. 3 types. I can definitely share later on. If it's required, I can send it via Tiffany while when she'll share recording, she can share those links as well. I can share that, Chuck.
Perfect. Is cybersecurity potent enough to handle offensive, malicious attacks?
So yeah, okay. So cybersecurity is capable. As I said, when you're dealing with too much data, too much these kinds of attack, when you're dealing with too much data, minimum workforce, and it's like you have to predict attacks before they happen, or even if they happen, you want to handle them better. So in any of these scenarios, you need to operationalize your operations. So for better optimizations, we highly recommend machine learning because that's going to be the future. The number of data is not going to increase.
Are cyber attacks also using machine learning? Is it a constant tug of war to outpace the other party? It's a good question.
Yes, you never know, because attackers are also evolving. So they are also learning like how the other side is evolving, like how the defensive side is evolving. They are also learning. So when I say they are becoming more sophisticated and evolved, definitely they have this knowledge. They are also using it for their own purpose.
Is this course a certification or degree? I can answer that. It's a certification, and we're not an accredited university, but we do teach you over the 15 weeks everything you need to learn in cybersecurity to get like your cyber cert. You would have to go and do that on your own at the end and get hired at an entry level cybersecurity job. Do you want to talk a little bit more about that, Asta, or does that work for you?
So prerequisites. So basically, if you want to self-study, you can self-study, but internet is full of things. So you will always need a mentor or a boot camp like us so that you can guide you better, because internet is full of so many materials, so many things. Often you are stuck between what to do and what not to do, and people might suggest you. So if you already know people, if you have friends, and if you have any seniors, definitely they can guide you better. So you might need a mentor, or you might need to sign up for a small course to get first understanding of what it is, and then you can take it to the next level.
Got it. How much I don't know if that's the right word, Postgres or parsing.
It's Postgres. It's kind
Thank you. Data using terminal commands are required.
So Laura, I have not used Postgres yet, so I have no idea about that.
Where is it possible to see available boot camps for machine learning that we host? Well, machine learning is both in data science and in cybersecurity. Do you want to talk about the cybersecurity side of things, Asta? Do we teach? We teach machine learning in
a bit of it. We do touch those sections of false positive, false negatives, machine learnings. Yes.
Got it. So we also teach it in the data science side of things as well. You can always go to flatironschool.com and look up our courses to learn a little bit more about that. And I know in our follow-up email, there will also be some links to our courses and some free content that you can utilize as well. What are the, we already talked about prerequisites, right? Or what is, yeah, we talked about that. Sorry, I missed it. When it comes to machine learning, is Python the only programming language used?
Now there is Python, there is R, and you can use other kind of programming languages as well, but they are most often used. That's the reason. So R is one of the language, Python is one of the language. The 80% of the people that I know personally who are in this area, they use Python or R.
Got it. How does the cybersecurity bootcamp differ from AWS machine learning specialty certificate?
So AWS machine learning certificate is like specially based on how AWS is utilizing machine learning and what's they are offering, like what's they're offering in their AWS services. So what we offer is general, it's not vendor specific. So AWS would be a vendor specific machine learning certificate. Ours is a like it's machine learning, and you're going to learn vast variety of knowledge about machine learning, not just AWS specific.
Awesome. What is a typical workday for a cybersecurity dev?
So for cybersecurity developers, so basically for a cybersecurity developer nowadays, so you must be working in a DevSecOps environment, which is development, security, and operations. So your day might start with like, first of all, like how does most of the developer days goes to like writing code, debugging code, testing code, then moving from one node to another. So moving from developer to test to another. So it's like in general, it looks like this, like a normal developer, but now when security is integrated to it, and most of the tools like GitHub or any of the Microsoft tools, which is integrated for your development environment. So in that sense, when you are testing and debugging the code, you might have to check for security related vulnerabilities and gaps as well. And you not only have to like fill those gaps for your from a developer's perspective, you have to fill those gaps from a security perspective point of view. You might be in touch with the testing and the security testing team and your operations team. So it's like a quite close job where you are interacting with your security testing and operations team, and you're either coding, reviewing the code, fixing gaps, maybe related to your general code or maybe security specific.
We have about 7 minutes left. There's a lot of questions in the chat, so we're going to try to get around to most of them, but please bear with us. For someone wanting to start learning machine learning, what is something you'd recommend they start experimenting with?
So basically, you can start with Python and start with sklearn. So sklearn is one of the Python libraries that you can utilize. It supports variety of machine learning models and algorithms. So you can start to test with that.
Is there any career advancement in cybersecurity? I just wanted to get
Of course, 100%. Cybersecurity is what we have along with data science now.
And for Python and R, do we teach that as a part of the course?
So in cyber, we do teach Python and R, if you're referring to, so that we have to check with the machine learning course if they teach R as well, but Python for sure.
Got it. What does deployment look like for putting these machine learning models in production? Are you using a platform like Azure to connect your network's data to a model? That's from the chat. From 548 or 848 on your time, sorry.
Okay, what does deployment look like for putting these machine learning models in production? Are you using a platform like Azure to connect with your network's data to a model? What does deployment look like for putting these machine learning? I didn't exactly get your word. What type of deployment you are looking for? So you're just saying deploying the machine learning models in the production. So if you're saying that, it can be Azure, it can be AWS, or it can be any on-premise platform. It's not exactly all the time, like it can be any of it, depending upon which services are you using.
Got it. Would it be possible to develop a defense tool that uses machine learning to detect an attacker before they gain access?
So basically defense, okay, so there are cybersecurity tools which have integration with machine learning. So you might see intrusion detection systems, you might see intrusion prevention system, you might see SIM tools like Splunk, Logarithm. They have integrated toolkit for machine learning. So definitely we are using machine learning in our security operations with the existing security tools. So it's not like it's something separate and we have not used it yet. We are already using it. We are already utilizing them in our operations.
Are there any conferences for cybersecurity or machine learning that you've attended in the past and gained a lot of value from?
Yes, so one is from Splunk. We have SplunkCon happening every year. So this year it will happen in November. And for cybersecurity, we have Black Hat Europe coming. You can sign up for Black Hat Europe. They provide business passes for free. So you can check their website and you can click on the business pass and register for it. OWASP is coming second week of November. You can also check for that. And I think majority of the conferences have already taken place, like Black Hat USA, RSA. So they have already happened. They are going to happen again next year. So to our left, Black Hat Europe and OWASP Global AppSec and SplunkCon.
Awesome. Between using Windows and Linux, which operating system is recommended when working in machine learning? And are there any restrictions or downsides?
I don't think so. From machine learning point of view, there is any specification related to operating system. I don't think so.
TensorFlow, does that work into play at this level for machine learning? And do you use it?
No, I don't use TensorFlow. I have not used it.
Got it. Are there any examples of machine learning based programs for intrusion detection systems or intrusion prevention systems?
So yes, any latest intrusion detection or prevention system, they are using machine learning, how they are becoming more adaptive. So earlier, your intrusion detection and prevention systems, they were based on signature based approaches. Now they are more adaptive. So how they are adaptive? So of course, in the back end, we are using either decision tree, XGBoost, or k-means clustering type of algorithms to predict basically any kinds of threats in a more proactive manner, specifically malware, where codes can be tweaked.
And then after being certified, after getting a certification from Flatiron, will someone be 100% educated to get a 75,000 paying job?
Sure. I think even yes, 100%.
Awesome. And then the last question, I think, is more on a personal side that I see here is, do you have Twitter, and do you mind sharing your Twitter handle?
Yeah, sure. I can share it in the chat. So it's my name followed by 189. That's my Twitter handle.
Awesome. And that seems like all the questions that we have here in the chat and in the Q&A. Asta, thank you so much for your time and your presentation. I'm just going to share my screen for 2 more seconds just to get to these last few. We already went through the question part, but if you're inspired to learn more about cybersecurity or just want to spend some more quality time with us, our upcoming cyber-related events are happening, and we're having a lot of them. There are a ton of them because October is Cybersecurity Awareness Month. So just about once a week, there will be an event. So please come join us for any or all of them. They will be included in the email as well. And if you're ready to break into the in-demand field of cybersecurity, we encourage you to get in touch with our admissions team. That link will also be provided to you in the next day. You can also do a casual 10-minute chat just to kind of talk about your options, or you can apply to Flatiron School or Secure Set by visiting our site. That is all we have this evening. Thank you so much again for joining us, and we hope to see you at all of our events in the next coming weeks. Have a good night, everybody. Cheers.
Bye, everyone. Thank you for joining.